Okay, so electrons transferred. This is what happens with ionic compounds. We learned earlier that ionic compounds contain metals and nonmetals. And what happens is the metal transfers electrons to the nonmetal. So the metal becomes a cation, positively charged, because it has lost some negative charges. The nonmetal becomes an anion because it's gotten some extra negative charges. In Lewis theory, we represent this by moving the electrons, the dots, from the metal to the nonmetal. So let's look at that. We're going to look at potassium and chlorine and see, oops, wrong button, see how they could transfer electrons to get octets. So let's start with the Lewis structures for potassium and chlorine. So here's potassium. How many valence electrons does potassium have? Just one. And here's chlorine, and it has 7. 1, 2, 3, 4, 5, 6, 7. They want to have 8 valence electrons. So chlorine is like, I've got 7, I am so close to 8, I just need one more electron. Hey, potassium, could you give me that electron, please? I just need one more electron. And potassium's over here. Let's just very quickly look at the electron configuration for potassium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So this is the valence electron. If potassium gets rid of that one valence electron, then the third level becomes the valence level. And how many electrons are in the third level? 8. So this is a little like peeling a skin off an onion, right? That one electron, there's just a little piece of the onion skin, and if you pull that off, underneath is a nice complete layer of onion skin. So potassium is looking to get rid of this electron, because if he gets rid of that, then underneath he has 8 valence electrons. So potassium says, sure, I was looking for somebody to take this from me. So he transfers that, and now potassium has a positive charge. We're not going to draw the electrons that were in the lower levels, because in Lewis theory, when we're moving electrons around, the number of dots stays the same. And so it would be confusing if all of a sudden 8 more dots showed up. But now chlorine is going to have 8 valence electrons because it's got that one it took from from potassium. And this has a negative charge. That negative sign can get kind of lost in all the dots. And so by convention, we generally put brackets around the Lewis symbol and put the charge on the outside. I didn't put any brackets here because there aren't any dots, and so it's not so confusing. Any questions? These are going to form an ionic compound, an ionic bond, because the positive charge on the potassium ion is attracted to the negative charge on the chloride ion. And so like two magnets are going to stick together. So the chloride ion has an octet. The potassium lost that one electron on the outside. Underneath it has a full octet. And then here's just another little quirk with mastering chemistry. The charges are shown when you draw Lewis structures for ions, but you don't put brackets in. You know, they have those little drawing tools and stuff. Apparently, they have not figured out how to do brackets. Seems a little lame to me, but they don't know how to do brackets. So please don't text me, how do I put the brackets? You can't, and it'll be correct without them, but you do have to show the charges. So let's look at sodium bromide and write the Lewis structure for this. So we've got sodium and we've got bromide. Let's start with just the atoms. So sodium has 1 valence electron, and bromine has 7. 7. So these guys are going to cooperate and help each other out so that they can both have 8 valence electrons. The sodium, is going to donate its electron to the bromine. So many letters. So I'm taking this electron from the sodium, and that results in the sodium having a positive charge. And I'm going to give that electron to the bromide, and that results in the bromide having a -1 charge. And so that would be a Lewis structure for sodium bromide. We don't often actually write Lewis structures for ionic compounds, but it's a good place to start because it helps us to understand what's going on. Any questions? Lewis theory does help us to predict formulas for ionic compounds. So let's look at barium fluoride. We learned how to predict its formula based on charges that we predict from the periodic table. How many valence electrons does barium have? 2. And how many valence electrons does fluorine have? 7. 1, 2, 3, 4, 5, 6, 7. So fluorine is going around looking for someone to give it an electron, looking for a handout. Barium is looking for someone to take an electron off its hands. 2 electrons, actually. Because electrons don't just fall off and bounce on the floor. They have to be handed to someone else. They have to go from one atom to another atom. You can't go to the store and buy electrons, or the bank or anything. There's no shelter for homeless electrons. You just have to get them from someone else. So we can take one of these electrons and give it to this fluorine. So I'll take off one of barium's electrons and give it to the fluorine. This fluorine now has a negative charge, and the barium has a positive charge. And the barium's like, hey, take this other one too. Is the fluorine going to take another electron? No. It's like, no, thanks for that one, but I'm set now. I don't want your other electron. So what's barium going to do? Well, if there's one fluorine atom around, there's probably like 3 gazillion other fluorine atoms around too. So he's going to find another fluorine atom. So here's this fluorine atom over here saying, hey, I'll take that extra electron from you. Do you like how these guys talk to each other? I can do it with atoms, can't do it with Hot Wheel cars. So we're going to take this electron from barium and give it to this other fluorine atom. So put that over there. This fluorine now has a -1 charge. 8 valence electrons, is super happy. And now the barium has a +2 charge. These 3 ions together overall have 0 charge. No electrons were created or destroyed. The number of protons all stayed the same. The only thing that happened is we kind of shifted around who had the electrons. Barium passed them off to the 2 fluorines. Any questions? So, use Lewis theory to predict the formula of the compound that forms between magnesium and nitrogen. We could do it from the periodic table, but that'd be no fun. Okay, so magnesium, how many valence electrons? 2. And nitrogen, how many valence electrons? 5. So what does magnesium want to do? It wants to lose those 2 extra electrons, right? So nitrogen is looking for electrons, so he's happy to take them off magnesium's hands. So we're going to take these 2 electrons from magnesium and give them to nitrogen. So poof, that one's gone and this one's gone. And we're going to give them to nitrogen. Now this has created charges. This magnesium now has a 2+ charge. And what's the charge on this nitrogen? -2. Is everybody happy? No? Magnesium's happy, but the nitrogen needs one more electron. Well, if there's one magnesium atom around, there's probably 3 bazillion others. So let's bring in one of those standing off to the side there. Here's another magnesium atom. 2 electrons that it's trying to get rid of. Here's a nitrogen. It wants one more electron so it can get 8. So we're going to take one of these electrons from the magnesium and give it to that nitrogen. Now the charge on the nitrogen is 3-. This magnesium has a +1 charge. Everybody happy? No. This magnesium's like, man, I'm so close. I just need one more. Who's he going to ditch that electron to? Another nitrogen. So here's another nitrogen atom. 5 valence electrons. This nitrogen atom's very happy to take that magnesium's electron. So here we go now. This is a 2+. And what's the charge on this nitrogen? Just -1. It got 1 extra electron, so it's -1. Everybody happy? No. You feel like this is going to go on and on forever? This is like my Grandma Johnson at dinner. I bet you didn't know that Lewis theory could relate to your grandma at dinner. It does. Bread and with it. With it was butter, jelly, jam, whatever. So she'd take some bread, some rolls, and she'd take some jelly, and then, she'd eat the roll with the jelly on it, and then she has jelly left over. So you have to take another roll. But there wasn't quite enough jelly left for that roll. So then you have to take more jelly. You can see how she could go on and on eating bread and with it all night long. And that's what this feels like, but it is going to come to an end.
It's more like when you have cookies and milk.
Cookies and milk?
Yeah, you finish your cookies and you have some leftover milk. So you're like, well, now I need more cookies.
I need more cookies. Yeah, and then you run out of the milk, and so you get more. Yeah.
Well, now I need more milk.
Right? It just goes on and on. So here, this is magnesium and nitrogen instead of bread and with it or milk and cookies. And so we need another magnesium atom in here with 2 valence electrons. We are coming to the end here. Magnesium is trying to get rid of 2 electrons. This nitrogen needs 2 because it only got 1 before. So we're going to take these 2 electrons, give them to the nitrogen. Now the charge on that nitrogen is 3-, and the charge on this magnesium is 2+. And those 5 ions, as they group together, overall, have 0 charge. Because no electrons left or came in, they just moved back and forth. Does that make sense?